All right, today we are jumping into the absolutely fascinating world of multi-agent systems. It's a really powerful AI concept, and believe it or not, it's inspired by some of nature's best team players. Let's dive in.
You've seen this, right? A huge flock of birds twisting and turning, moving like a single entity in the sky. Or a school of fish that just instantly dodges a predator in perfect sync. It always makes you wonder, who's giving the orders? The incredible answer is, well, it's kind of mind-blowing. No one.
So that phenomenon, that incredible leaderless teamwork you see in nature, it's more than just a pretty sight. It's the exact blueprint for the powerful AI technology we're going to talk about today.
So here's the big idea. You don't actually need a central commander to get things done. Instead, you can have this incredibly complex, intelligent group behavior, what scientists call emergent intelligence, that comes from individuals just following a few simple rules. All they do is react to their immediate neighbors. And when computer scientists saw this happening, they had a brilliant thought. What if we could build digital teams that work the exact same way?
Okay, so with that blueprint from nature in our back pocket, let's make the jump into the digital world and get a clear definition of what a multi-agent system really is.
At its core, a multi-agent system, or MAS for short, is basically a team of independent computer programs. We call them agents. They work together, but here's the real key. They're designed to tackle problems that are just way too big, too complex, or changing too fast for any single agent to handle by itself.
This slide lays it out perfectly. A traditional, monolithic system is like an old-school factory with one single boss. If that central controller goes down, the entire operation just grinds to a halt. That's a single point of failure. But a multi-agent system? It's completely decentralized. It's resilient. If one agent fails, the others just adapt and keep the mission going. They're built from the ground up to be fault-tolerant and can even recover on their own.
So, we know these digital teams are super resilient. But what actually makes an individual agent, well, an agent? Let's break down the core ingredients. It really comes down to three key things. First, each agent has autonomy. It makes its own decisions. Second, and this is so important, each agent only has a local view. Just like a single bird in that giant flock, it can only see its immediate neighbors. It has no idea what's happening on the other side of the system. And finally, the whole system is decentralized. No boss, no central command. And that's exactly where it gets its strength.
Okay, so we've got all these autonomous agents, and each one only has a tiny view of the world. The big question is, how on earth do they coordinate to do anything useful? Let's look at the power of the swarm and how their simple interactions create something incredibly intelligent.
A really common way they communicate is the pattern you see right here. First, an agent broadcasts a challenge. It's like shouting out into a crowd, "Hey, who can help me with this?" Then, any agents that have the right skills put in a response. They basically raise their hand and say, "I can do that, and here's my price." Finally, the original agent picks the best offer, and they form a contract. It's a super simple, dynamic, and totally decentralized way to get tasks done.
And this is where the real magic happens. This quote just nails it. Multi-agent systems manifest self-organization even when the individual strategies of all their agents are simple. So you get this sophisticated, intelligent behavior from the entire group without any master plan. It's all just simple rules followed locally. Amazing.
Now, I know this might all sound a bit abstract, but I guarantee you have seen multi-agent systems at work without even knowing it. This technology is already all around us. Let's look at just a few real-world examples.
Okay, think about disaster response. In a chaotic crisis, you have to adapt constantly. A multi-agent system is perfect for this. It can coordinate all the logistics for everything from rescue teams to critical supplies. And it can reroute those resources in real time as the situation on the ground changes.
Here's a fantastic one from the world of self-driving cars. Waymo built a simulation called CarCraft. It's basically a digital city that's populated by thousands of AI agents, all acting as drivers, cyclists, and pedestrians. This lets them test their algorithms in millions of chaotic scenarios before a single car ever has to hit a real street.
If you've ever watched an epic movie battle with thousands of soldiers, you've seen a multi-agent system. Instead of animating every single person, artists just create a few simple rules for these digital agents. Like run towards the enemy, or try not to run into your friends. And the system automatically generates these complex, believable crowd movements.
The applications in industry are just huge. Agents are used to balance the load on smart power grids, moment by moment. They're used to optimize the flow of traffic in our cities, and they manage these incredibly complex global supply chains.
These are all massive, dynamic problems that are just perfect for a decentralized approach.
And the scale gets even bigger. Researchers are now using agent-based models to simulate entire societies. This lets them study hugely complex phenomena, like how a disease might spread through population, or the ripple effects of a new economic policy, in a way that was just never possible before.
So the technology is already here, and it's incredibly powerful. But where is it all going? For our final section, let's take a look at what the future holds for collaborative AI.
The next major leap is already happening, and it involves integrating large language models. You know, the same tech behind tools like ChatGPT. And this is a total game changer. It gives agents the ability to understand complex instructions, to negotiate, and to coordinate in much more sophisticated, almost human-like ways. This elevates them from just being simple rule followers to being true digital collaborators.
And that brings us right back to where we started. We looked at those simple, leaderless teams in nature. Now, we're on the verge of creating digital teams that can learn and reason and collaborate on a global scale. So the final question I'll leave you with is this. As these AI teams become ever more powerful, what impossible problems in science, in medicine, in society will we ask them to help us solve next?